Three astronauts came home this week after 241 days off the planet. The sun did something twice this week that it almost never does. A rover that's been on Mars for over a decade is finally starting to get beat up, and we have images of it. And finally, a high schooler wrote a paper telling astronomers that they may be looking for aliens in the wrong way. Stay tuned. On Sunday, July 26, the Soyuz capsule came down under the parachute onto the steppe out in Kazakhstan. Inside it were three astronauts coming home from the International Space Station. NASA's Chris Williams and two Russian cosmonauts. They'd been up there 241 days. That's about 8 months long. Enough that the station's crew rotated around them while they stayed. They got there during Expedition 73 and left during 74. And here's the part that I think gets glossed over when these missions end. Coming home is hard on the body. In microgravity, your bones lose density. Your muscles weaken because they're not fighting gravity anymore. The fluid in your body redistributes towards your head. Crews exercise about 2 hours a day up there, specifically to fight that, and they still come back needing help walking. That's why you always see them being carried out of the capsule and set down in chairs. It's not that something went wrong, it's that gravity, after 8 months away from it, hits like a wall. Next up, the sun spent this entire week actually throwing things at us. It started early on July 24th. At about 12:30 in the morning Eastern Time, a large filament lifted off the sun's southern hemisphere, right near the middle of the disk as we see it from here. And a filament is just a rope of cooler, denser plasma held up above the sun's surface by magnetic fields. Cooler is a relative term here. We're talking tens of thousands of degrees instead of the million plus in the corona surrounding it. When the magnetic fields holding up that rope lose their grip, the whole thing erupts and throws plasma out into space. That's what's called a coronal mass ejection, a CME. And that July 24th eruption came with a small flare and something called coronal dimming, a localized drop in ultraviolet brightness. That dimming is usually useful to us. It's a reliable tell that plasma genuinely left the sun rather than just shifting around. 2 days later on Sunday, the 26th, an active region labeled AR4494 fired off a moderate flare of its own, an M3.2 peaking around 11:30 in the morning Eastern Time. That one launched its own CME aimed our way. Finally, Monday, the 27th, at about 2 in the morning Eastern Time, the biggest one, a massive filament erupted right on the center of the sun's central meridian, its midline just north of where that line meets the solar equator. And here's the part that makes this one unusual. At almost the exact moment that that filament let go, a huge prominence appeared way out over the sun's northwest edge. Now, a prominence and a filament are actually the same kind of structure. The difference is just where you're standing. Over the middle of the disk, we call it a filament. Out on the limb, silhouetted against black space, we call it a prominence. So two of these things on opposite parts of the sun going off essentially together. So there's now a queue of solar material headed our way, arriving at different times. The July 24th blast has already hit us. It set off a geomagnetic storm earlier this week. The one from the 26th is forecast to arrive late on July 30th. And the 27th eruption sent a component our way too, though that one's expected to be a faint glancing blow somewhere around August 1st. On top of all of that, there's a large coronal hole sitting over the sun's central meridian right now. That's a gap where the magnetic field opens up and lets fast solar wind escape. It's positioned a little too far south to face us squarely, but part of that wind may still reach us. So add it all up, and forecasters were only watching for minor geomagnetic storms around the 30th and to the 31st. And that's the fun version of this, right? The aurora borealis at high latitudes. The less fun version is that this is the same activity as what disrupts radio communication and puts satellites at risk. Alright, changing gears. New close-up images this week gave us a look at the wheels on NASA's Curiosity rover, and they're in rough shape. Curiosity landed on Mars in August of 2012. That's 14 years of driving across terrain that is, to put it plainly, not friendly. Its 6 wheels are made of thin aluminum, and Martian rock is very sharp, embedded, and doesn't move out of the way. Over the years, those wheels have picked up punctures, tears, and worn through sections. What I find genuinely interesting here is how NASA responded to it. Engineers noticed wheel damage showing up way earlier than expected, and rather than just accept it, they changed how the rover drives, adjusting routes and updating the software that controls how it handles rough ground, specifically to reduce the stress on the wheels. So, the wheels look bad, but the rover's still going well past the mission it was originally designed for. And that's the story here. Not necessarily that it's breaking down, but that it's been breaking down for a decade and still hasn't stopped. Okay, finally, my favorite one of the week. So, one of the more famous ideas in the search for intelligent life is something called a Dyson sphere. That concept is that a sufficiently advanced civilization would eventually want to capture as much of their star's energy as possible. So they'd build an enormous structure around it, a swarm or a shell, just something to collect that energy. And the way astronomers have proposed hunting for one is by looking for waste heat. The reasoning goes, if you're collecting that much energy, physics says you have to dump excess heat somewhere, and that heat should show up in infrared. So we've been scanning for stars that look strange in infrared. And here's the twist. A high school student in Turkey published a preprint this week arguing that we may be looking for the wrong signature entirely. That assuming a specific kind of waste heat could mean we're filtering out exactly the civilizations we're trying to find. Now, quick honesty check because this matters. This is a preprint, meaning that it hasn't been through formal peer review yet, not a finding. But that's not a knock on it. The whole point of a preprint is putting an idea in front of the field to be argued with. And a high school student getting a serious methodological argument into that conversation at all is genuinely remarkable.
So that's this week. 3 people readjusting to gravity, a sun that fired twice at once, a rover that refuses to quit, and a teenager telling us how we're looking for aliens wrong. Let me know which one of these stories grabbed you the most. And don't forget to look up. Thanks.